China has sent a devastating weapon into the skies, and even the United States' most formidable ships are vulnerable. The hazards posed by unmanned aerial vehicles have recently escalated at an alarming rate, and the United States has now taken action to defend itself against these aircraft. The United States has outfitted its ships with the most lethal armaments in the world. What are these weapons' capabilities? Are they strong enough to defend these aircraft carriers against the expanding aerial threats? Watch us examine some of the most lethal U.S. Navy weapons. The United States Navy is known as the world's greatest and most powerful naval force. The U.S. Navy, with over 90,000 active people and around 484 warships, is critical to America's military might and national defense. The U.S. Navy's fleet of 11 nuclear-powered aircraft carriers, including the advanced Gerald R. Ford and Nimitz classes, is a critical component of military strength. These carriers serve as mobile air bases, providing unparalleled adaptability and combat capability for deploying air forces anywhere in the world. Each carrier is supported by a strike group of destroyers, cruisers, and submarines, resulting in a formidable maritime force. The U.S. Navy's surface fleet consists of around 70 Arleigh Burke-class destroyers and 22 Ticonderoga-class cruisers, both equipped with the Aegis combat system. This modern system uses sophisticated radar and missile technologies to provide outstanding air defense, anti-submarine warfare, and ballistic missile defense. Furthermore, littoral combat ships provide flexibility and speed, particularly in coastal zones. Another major aspect of the U.S. Navy is its submarine fleet, which comprises both rapid assault and ballistic missile submarines. The Virginia-class SS&S are intended for stealth, reconnaissance, and strike capabilities, while the Ohio-class SSB&S play an important part in the U.S. nuclear deterrence policy. Recently, modern battleships have faced major challenges from new technologies, such as drones and other stealth unmanned aircraft. On October 4, the USS Gerald R. Ford, the newest U.S. aircraft carrier, set sail for its first deployment amidst rising tensions in the Pacific and doubt about the future role of such massive ships in battle. Standing over 9 floors tall, the ship weighs 97,000 tons, 32,000 tons more than the heaviest battleships from WWIII. The fort is amazing in size. However, it is also fast, powered by modern A-1B nuclear reactors that generate approximately 300 megawatts of power, making it nearly 3 times more powerful than contemporary supercarriers. Despite their power, new Chinese anti-ship missiles capable of speeds greater than Mach 5 represent a huge threat to the fort and the entire Pacific Navy fleet. These rockets might kill even the most modern ships. To combat these new threats, the Navy is using sophisticated long-range weaponry such as universal ship installations, railguns, and lasers, which may revolutionize future warfare. Let's examine some of the technology that could safeguard these costly and crucial ships from aerial threats. Let's start with a unique firearm, the Automalera 76. This 76mm gun, also known as the OTO-76/62 gun mount, is a naval autocannon manufactured by Italian manufacturer Automalera. This gun is tiny enough to fit on a smaller vessel. It has a high firing rate and can use a variety of ammunition, making it ideal for close-range defense against missiles, aircraft, surface targets, and ground support. The ammunition comprises armor-piercing, incendiary, and guided rounds intended to hit moving anti-ship missiles. It can also be concealed in a stealthy dome. The Automalera 76 gun's capacity to execute many duties such as short-range anti-missile defense, anti-aircraft operations, and ground support is one of its most notable attributes. The gun's rapid rate of fire, paired with a wide range of available ammunition, makes it more effective in a variety of combat circumstances. The cooling system of this gun uses seawater, while fresh water is used for flushing. The gun's electrical power supply consists of a 4-voltage, 3-phase, 60 Hz main circuit and a 115 voltage, 1-phase 400 Hz servo and synchro network. This electrical arrangement ensures that the gun functions properly under a variety of scenarios. The OTO Malera 76mm cannon comes in a variety of configurations, each tailored to specific operating needs. The original tiny model had a circular dome. It has a firing rate of 85 rounds per minute. The super rapid version was released in the early 1980s, and it features a diagonal dome as well as a substantially faster fire rate of 120 rounds per minute thanks to an upgraded feed system. The super rapid variant's increased rate of fire makes it particularly effective in high-pressure combat scenarios. The Strel system is another significant upgrade to the OTO Malera 76mm cannon. The Italian Navy prefers this type because of its improved anti-missile defense capabilities, especially when equipped with DART ammo, which allows it to counter multiple subsonic missiles at ranges of up to 8,000 meters. This medium-caliber pistol is also effective against surface targets, demonstrating its versatility on the field. Another novel invention is the 76/62 Sovrapont, a new compact and lightweight mount for the 76/62 pistol. This system weighs roughly 30 to 40% less than the normal Super Rapid and may be installed without entering the deck below. It holds 76 ready-to-fire rounds and is available for purchase with or without the Strel system. The Sovrapont mount was first deployed on the Italian Navy's Theon de Rebel-class patrol vessel, above the helicopter hangar, emphasizing the gun's adaptability through its small form. OTO Malera offers a diverse assortment of customized ammunition appropriate for a variety of combat roles. The available varieties include high-explosive standard rounds weighing 6.296 kg and with a range of 16 kilometers. Other ammunition types include multi-role ATO munition, anti-missile projectiles with proximity fuses and tungsten balls for fragmentation, and semi-armor-piercing SAPOM rounds with a 16-kilometer range. The guided dart projectile is intended for engaging and moving airborne and missile targets, whereas the Volcano-guided projectile, weighing 5 kilos, has a range of around 40 kilometers. The fire control systems of the OTO Malera 76mm cannon have also improved significantly over time. Early versions, such as the compact variant, used the RTN-10X Orion radar. Later, in the early 1980s, the more sophisticated RTN-30X radar was introduced. This new system can handle a variety of calibers, including 40, 76, and 127 millimeters, as well as missiles such as the Sea Sparrow and Aspide. The RTN-30X system first saw duty with the Italian Navy on the Garibaldi cruiser, and it has since been installed on a number of destroyers and frigates. The O2 Malera 76mm gun is a versatile and widely used naval autocannon that has evolved significantly since its introduction. The gun remains an important weapon for modern naval forces, with several types available, including the compact Super Rapid and Sovrapont, as well as a wide selection of ammunition and superior fire control systems. Its flexibility to perform numerous functions, along with unique design features, guarantees that it will continue to play an important role in naval operations for many years to come. Another weapon is the Phalanx CIWS. It's an automatic gun system designed to protect military ships. General Dynamics, now part of Raytheon, built it to protect against threats like airplanes, missiles, and small boats. The system includes a radar-guided 20M Vulcan cannon that can swivel to target approaching threats. The Phalanx is utilized by the United States Navy and 15 other countries, and it is installed on practically all U.S. surface combat ships except the Zumwalt-class destroyer and the San Antonio-class amphibious transport dock. Other users include the British Royal Navy, the Royal Australian Navy, Royal New Zealand Navy, Royal Canadian Navy, and United States Coast Guard. The Land Phalanx Weapon System, LPWS, was developed as part of the counter-rocket, artillery, and mortar system. It was employed to defend against rocket, artillery, and mortar attacks as the United States prepares to leave Afghanistan in 2021. The U.S. Navy also uses the CRAM technology. This combines the RIM-116 rolling airframe missile with sensors similar to those found on the Phalanx. It was designed as a last line of defense against approaching threats such as anti-ship missiles, aircraft, and small boats. The U.S. Navy tested the first prototype on the destroyer leader USS King in 1973, following which adjustments were made to increase performance and dependability. In 1977, the Phalanx operational suitability model was successfully tested on the destroyer USS Bigelow. This model completed all maintenance and reliability requirements, resulting in its production certification in 1978. The first orders were 23 for the U.S. Navy and 14 for foreign military systems. The aircraft carrier USS Coral Sea was the first fully equipped ship in 1980. The Navy also began putting CIW systems aboard non-combatant warships in 1984. The failed system is based on the 20mm M61 Vulcan rotary cannon, which the United States military has utilized on various aircraft since 1959. It uses a Q-band fire control radar system to locate and track targets. The device is positioned on a platform that can quickly move up and down, as well as side to side, to track incoming threats. This device includes both the gun and the automated fire control system. Other major components enable it to automatically search for, detect, track, and engage targets using its computer-controlled radar. Its self-contained architecture makes it ideal for support ships, which typically lack advanced targeting systems and limited sensors. Phalanx CIWS units are frequently dubbed R2-D2 due to its round radar form and automated function, which resembles the droid from the Star Wars films in April 2017. Raytheon tested a new electric cannon for the Phalanx, which can fire at varying rates to save ammunition. This innovative design replaces the pneumatic motor, compressor, and storage tanks, reducing the system's weight by 180 pounds while increasing reliability and saving operating expenses. The United States has also invested in cutting-edge weapons to make its aircraft carriers more formidable. Some of this weaponry includes railguns and laser weapons. People often refer to a railgun as a rail cannon. This weapon utilizes electromagnetic force to propel projectiles at high speeds. Unlike traditional weaponry, projectiles do not usually contain explosives. Instead, they exploit their enormous kinetic energy to produce damage. A railgun consists of two parallel metal tracks that employ an electrical current to accelerate a sliding piece between them. This is comparable to how a homopolar motor operates. As of 2020, research has centered on employing railguns as weapons. They have the ability to shoot projectiles at considerably faster speeds than traditional weapons. Traditional guns can normally fire projectiles at rates of up to 2 kilometers per second. However, railguns can easily exceed 3 kilometers per second. This increased speed can offer railgun projectiles a longer range and greater destructive power, depending on their kinetic energy when they strike a target. Railguns do not require explosive propellants, hence, the projectiles are less expensive and safer to handle. However, research on railguns is currently primarily focused on this area. Despite many years of development, it is unclear whether they will become useful military weapons very soon. Any comparison between electromagnetic propulsion systems and standard chemical propellants must take into account aspects such as durability, availability, cost, and the complexity of the power sources required by electromagnetic launchers. How do these railguns operate? The name railgun comes from the fact that it has two parallel metal tracks. The gun's back end is formed by connecting one end of the rails to an electrical power supply. A conductive bullet placed between the rails completes the circuit. This lets electrons go from the power supply to the projectile via one rail, then back down the other rail to the power supply. This electrical current causes the railgun to behave as an electromagnet, generating a magnetic field between the rails. According to the right-hand rule, the magnetic field flows around each rail. Because the electric current runs in opposite directions along the rails, the overall magnetic field between them propels the projectile forward along the rails toward the front end of the cannon. While forces attempt to push the rails apart, they are kept firmly in place and do not move. If a current of 1 amp travels through two long parallel wires 1 meter apart, the force on each wire is 0.2 micronewtons. In general, force grows as the square of the current. It diminishes as the distance between the wires increases. Railguns that discharge projectiles weighing a few kilograms and have barrels a few meters long require extremely high currents to reach speeds of roughly 1,000 meters per second. A massive power supply capable of producing approximately 1 million amps of current can provide a powerful force that propels the projectile at speeds of several kilometers per second. However, these high speeds produce a lot of heat, which can quickly wear down the rails. Rail weapons would require frequent rail replacement or the use of special heat-resistant materials. Experts concur that major advancements in material science are required to build powerful railguns capable of firing multiple times before requiring new rails. The barrel must sustain this pressure for numerous rounds before breaking down. The power supply must deliver big currents in a consistent and safe manner for an extended period. The most crucial indicator of a power supply's performance is the amount of energy it can provide. As of December 2010, the maximum energy required to fire a railgun bullet was 33 megajoules. Railgun power supplies commonly use capacitors and compulsators, which charge slowly from other energy sources. The rails must withstand high forces during firing, which can cause them to separate from the projectile. If the distance between the rails and the projectile widens, electrical arcs can form, damaging the rail surfaces. This limited early railguns to a single shot at a time. A railgun's efficiency is additionally restricted by the rail's inductance and resistance, as well as its power source. Different rail shapes and designs are being tested mostly by the US Navy and other research organizations. The rails and projectiles must be built of highly conductive materials that can endure the stresses of firing. Some studies falsely stated that the recoil force of railguns could be diverted. However, detailed research reveals that recoil acts on the breech closing in the same way as it does in traditional weapons. As with the projectile, the rails reject each other due to a sideways force from the magnetic field. They must be securely mounted to prevent bending. Major advances in material science are required before rails can be developed that allow railguns to fire more than a few full-power bullets before needing to be replaced. Railguns generate a lot of heat as electricity flows through the rails. The friction is created as the missile exits. This leads to three primary problems: the melting of parts, potential safety risks for personnel, and the enhanced heat signature that can be identified by hostile forces. To fire such a gadget, severe heat-resistant materials are required. If not, the rails and other equipment may melt or get damaged. Most railgun designs erode the rails with each shot. Projectiles may also wear out, drastically reducing the lifespan of the railgun. While railgun technology is still being researched, the United States has made significant advances in laser system development. Let's look at the features and capabilities of the US Navy's High-Energy Laser Counter Anti-Ship Cruise, or Hellcat missile project, which is moving closer to turning its developed technology into an operational system. Currently, there is one San Antonio-class amphibious transport ship. It comes armed with a 150 kilowatt Mark II Mode 0 laser weapon system demonstration. Furthermore, 8 Arleigh Burke-class destroyers are equipped with the optical dazzler Interdictor Navy, and one destroyer boasts a 60 kilowatt high-energy laser with an integrated optical dazzler and surveillance or helio system. Hellcat is not like these devices, which are intended for counterintelligence, surveillance, and reconnaissance by blinding or killing unmanned aerial vehicles. Hellcat primarily targets anti-ship cruise missiles in a crossing situation, allowing it to protect against missiles fired at surrounding friendly ships. After completing Phase 1 of the ruggedized high-energy laser, the US Navy launched Hellcat in 2019. Hellcat attempts to overcome technological challenges associated with laser weapons, such as enhanced beam control, atmospheric turbulence effects, precise tracking in cluttered situations, and autonomous target identification and aiming. Hellcat's results and years of technological progress will combine to form the laser weapon testbed, which will serve as the foundation for Hellcat. This testbed will employ a 300-plus kilowatt laser produced under the High Energy Laser Scaling Initiative, which has financed teams to provide increasingly strong lasers. The laser will be coupled with a Navy-developed prototype beam control system, as well as a power and cooling system. The LWT will be tested at the White Sands Missile Range this year. The initial tests will concentrate on the system's beam control, tracking, and optics performance. After that, it will be tested against increasingly complicated targets, beginning with fixed ground targets, progressing to moving targets, and finally low-cost unmanned aerial targets and cruise missile surrogates. Once finished, this initiative will contribute to the improvement of future systems based on the Surface Navy Laser Weapon System Increment 1. The program currently has no plans to leave any assets or prototypes for ship integration. Thank you for watching. While you're here, click the link on your screen to view another of our videos. See you there!